All right, this is Unit 4, Lesson 2, Practice number 1 in our guided notes. If you're looking in your packet, this should be labeled as page number 7 down at the bottom. On the other side should be a riddle worksheet about solving systems by substitution, but that is our topic today. So before we were solving systems by graphing both equations and then finding where they intersect. Today we're going to be calculating the solution by solving for x and for y. And so the steps to do this is to first rewrite one of the equations to be y equals by solving for y. So remember, we have to do that by solve for y. And then next, we're gonna substitute the value for y into the other equation. So we're gonna substitute, and then we are going to plug in, or we're gonna solve the new equation to find x, and then we're gonna plug in the value for x to one of my original equations. Then we can check our answer by plugging x and y both in to both equations. So that's a lot of steps. We're going to start with our first question. So when I have a system of equations, and sometimes you'll see they'll have like a curly bracket to show that I have two equations kind of happening at the same time. So an equation also shows me the relationship between x and y. So if I have these two equations, it's telling me that I want y to be equal to 3x, and I want x plus y to equal negative 32. I want both of those things to be true. So what we want to do first is rewrite one of the equations for y equals. That was step number 1. I already have that here because that first equation is y equals. It's solved for y. And so my next step is going to be to substitute the value for y into the next equation. So here my value for y is 3x. Y is equal to 3x. So I'm going to substitute that in for y. So when I rewrite that equation, I'll have here, that's a little bit bulky. But when I substitute it in, what will I have? I'll have x plus 3x equals negative 32. So I replaced y with what y was equal to. Why would I do that? Because now I only have one variable. I can't solve an equation when I have two things I don't know, but I can solve an equation when I have only one variable. So if I have 1x plus 3x together, that is 4x. And if that is equal to negative 32, I'm going to do the opposite operation of times 4, and I'm going to divide by 4 on both sides to keep my equation equal. And then I'll be left with x equals negative 32 divided by 4 is negative 8. So that is my x. Now I'm going to plug in the value for x to either one of the equations, whichever one looks easier, because now I'm going to use it to find y. So now it's not a mystery. Now that I know x, I can again find y because I'll only have one variable. I think I'm going to choose that first equation again because it's y equals. So I'm going to put that value back into my equation for y equals 3x. So if I know now that x is negative 8, I'm going to replace x with negative 8. When I plug in, a lot of times I'll do parentheses. It kind of reminds me what I plugged in. And again, when I have a number right next to the parentheses, that means multiply. So that means I have y equals 3 times negative 8, which is negative 24. So that is my solution. I found x, and then I use that to find y. And so together, if I imagine on a graph, that means that negative 8 comma negative 24 is where the two lines will intersect. And I did it without graphing. If I want to check, I'm going to take those two values, negative 8 and negative 24, and I'm going to plug them both back into my two equations, x plus y equals negative 32 and y equals 3 times x. So if I do that, I get negative 8 instead of x, right, plus negative 24 equals negative 32. Does it is the question, right? I have to make sure that it does, in fact, work out with a true statement. So here, yes, when I do negative 8 plus negative 24, I do get negative 32, thankfully. And then my next equation, negative 24, does it equal 3 times negative 8? It does. Negative 24 equals negative 24. So I am correct. All right, we're going to move on to number 2. So here I have y equals 9x minus 2 and y equals 3x plus 10. Again, I want both of those to be true. And our first step, looking back at our notes, is to rewrite one for y equals. They actually both are this time. So now we're going to substitute the value of y into the second equation. And so here I know it's a little bit longer, but I'm still just going to take this entire value of y and plug it in for my y. So then I would have 9x minus 2 equals 3x plus 10. So this is kind of a different situation. Now I have x on both sides. So this is one of the things, we have a poster hanging up in the classroom about x on both sides. My first step should be to eliminate one of those x's. So if I want to eliminate it to 0, I'm going to either add or subtract it to make it 0. So I'm going to go for the smaller one, which is 3x, just because it's positive 3x. So I know I'm going to subtract it to make it 0, right? So if I imagine x was a number, if x was like 2, this would be 3 times 2 minus 3 times 2, which would give me 0. I picked the smaller number because now when I subtract it, I won't get a negative. But remember, I have to do it to both sides. So I can only add and subtract variables with variables and constants with constants. So when I go to subtract the 3x from the left side, I'm taking it away from the 9x because those are both variables. I can't take away 3x from 2 because I don't know how much x is, but I can combine the 9x and the 3x. They're like terms. So 9x minus 3x is 6x's, and now I have minus 2 equals 0 plus 10, which is 10. And so now I can work on isolating my x. So first I'm going to isolate my 6x, get rid of that minus 2 to get x by itself. I'm going to do that by doing plus 2 to make it 0. And now I get 6x equals 12. Last step, I'm going to go from 6x to 1x by dividing by 6, opposite of multiplication. And now I'll have 6 divided by 6 is 1x. 12 divided by 6 is 2. So I get x equals 2. Kind of a lot of steps, but now we also have to plug it back into one of my equations. I think I'm going to choose the second equation. You can choose either one. The second one, maybe like I'm multiplying by 3 instead of multiplying by 9. That might be a little bit easier. So now I'm going to put it into this equation. Y equals 3x plus 10. And so what will happen is I'll have y equals 3 times x. Well, x is 2. We just found that out. So I'll have y equals 6. 3 times 2 is 6 plus 10. 6 plus 10 is 16. Yes. So I have my x and my y. So my solution is 2 comma 16. Done. X comma y. Check it. If x was 2 and y was 16, what would happen if both of my equations? Well, my first equation would be 16 equals 9 times 2, or when I plug in, we just talked about how I like to do the parentheses and then I didn't do it. 9 times 2 minus 2, it's glitching, minus 2. And I'll have for my other equation, 16 equals 3 times 2 plus 10. So those are my two equations, but now I replaced x and y with the numbers we have for x and y. So let's see if I get true statements. 9 times 2 is 18. So I'd have 16 equals 18 minus 2. Is that true? 18 minus 2 is 16. Perfect. Other side, we have 16 equals 3 times 2, 6, plus 10. Also true. 6 plus 10 is 16. So my work is checked. A lot of steps. Feels good in the end, though, to see them all worked out like that. Here are two more for you to try. Here, when I am multiplying, what is going to happen is we're going to review some distribution. So let's start this first one together. Maybe we'll do the first part of this one and you can check it. So again, solve one for y equals. It is already solved for y equals in the first one. Now I'm going to substitute in my value of y in for y. So I'm going to take this whole thing and plug it in here. This is where plugging in something in parentheses will really help, because now if I write my equation, right? So my equation is 5x plus 6y equals 13. I'm plugging in negative x plus 4 for y. So if I write my equation and I put what I'm plugging in for y in parentheses, I'll have negative x plus 4, right? That whole thing is going in for y. So keeping it in parentheses will help a lot, because now all of that is going to be multiplied by 6, right? It's 6 times y. So we're going to multiply 6 by everything inside. That's distribution. So I do my rainbow of like, I'm going to multiply negative x by 6 and 4 by 6. So what will I get? I'll get 5x plus 6 times negative 1x is negative 6x. 6 times 4 is 10. And that's equal to, oh, 6 times 4 is 10. Oh my gosh, what did I just do? 6 times 4, I added. 6 times 4 is 24, equals 13. So again, I can combine my x's together. 5x and negative 6x, that'd be like minus 6x. That would be negative 1x, or just negative x. So I can get rid of the 1. And then plus 24 equals 13. So to get x alone, I'm going to take away the 24 from both sides to make it 0, opposite operation. And I get negative x equals negative 11. So if I have 13, I take away 24. I could do the same thing of, I could do like 24 minus 13 and make it negative. If I switch, so see, I have negative x is negative 11. That does mean that positive x is positive 11. I could like add the x to the other side and add the 11 to the other side, or divide both sides by negative 1. But x is equal to 11. So now when I put that value into one of my equations, maybe I'll do the first one this time. Y equals negative x, right? So I'm plugging in 11. So positive 11, y equals negative x. So negative 11 plus 4 would be y equals negative 7. I almost wrote 6. I'm losing it today. So my final answer would be 11 comma negative 7, and you can check it by plugging in x equals 11 and y equals negative 7 back into both of my equations. Sometimes I might want my equation to be solved for y and it's not. So let's pretend that this second one is not solved for y. I would have to solve this first equation to be y equals. And so if you watch the video for the last lesson, you might know if I do that, um, I'll have negative 3x plus 4y equals 7. I would first eliminate my x term to get it onto the other side. So that would be 0. And I would be left with 4y equals 7 plus 3x. See here, in a lot of questions we'll do, it'll work out with better numbers. My last step then would be to divide everything by 4. Divide the left side by 4 and divide everything on the right side by 4. And I would be left with y equals 7 over 4 plus 3/4 x. But obviously, that's not the nicest equation. So when you go to solve number 4 now on your own, I would just use the two equations that were already written for you. That was just an example of how I could solve an equation for y. You might need to do that on the next page as you're working alone. So your next step might be to just, well, first of all, check number 3 and then go through number 4 on your own, plug in the value for y, and follow the steps as we did before. And then you can move on to the back side of this page, page number 8, to solve those equations and find the riddle.